This is the Gliss Video Manual. Gliss is a touch controller for your modular synth. In this video we'll walk you through everything you need to know to get the most out of your module. You can treat this video as a manual covering all of Gliss's modes and features, as well as a source of ideas for when and how to use Gliss. Gliss has 4 performance modes. First we have Control. In this mode, you can generate CV and gate signals based on your precise finger position and touch size. Next we have Record. This mode lets you draw waveforms directly into your system and record gestures of up to 75 seconds. You can either loop the gesture to create a custom LFO or trigger it like an envelope. Next up is Signal. Along with visualizing any signal in your system, this mode can clip, scale, offset and smooth control voltages performatively. Our final mode is Notes. This mode offers 5 notes at fixed, custom configured voltages. Use it as an expressive keyboard with 5 pressure-sensitive buttons, or play the notes like a step sequencer controlled by an input clock signal. But how do we navigate between these modes? This is where the menu comes in. We discuss the menu in depth in this video, but its main functions are to step between modes, to customize the mode you're in, and set the voltage ranges for the current mode. Gliss's main feature is a large capacitive touch surface called the touch strip. It senses your finger position with sub-millimeter accuracy and reads single or multiple touches depending on the mode. Additionally, the touch strip senses touch size, which refers to how much of your fingertip makes contact with the surface. This is broadly equivalent to pressure sensitivity. Pushing harder will result in a larger output and softer in a smaller. There's a physical button beside the jacks. You'll be using the button for triggering the playback of recorded gestures, arming Gliss for recording loops, and entering the menu in global settings. The button is illuminated and can display red, green and yellow colours. Gliss has an input jack for connecting external signals and a pair of outputs, a top one and a bottom one, for sending control voltages around your system. Gliss comes with a faceplate installed that places the jacks and button at the top. A second faceplate is available with the jacks at the bottom, so you can choose the orientation that works best for you and your setup. Getting comfortable with the menu is important for unlocking the full potential of Gliss. We use the menu to move between modes, customize its settings and configure its voltage ranges. To access the menu, hold down the button, tap the touch strip with 2 fingers and release the button. To exit the menu, tap the button. The green selector at the top of the menu cycles through Gliss's 4 performance modes. Tap the mode selector to step to the next mode. An animation representing the new mode will be played. Below the mode selector, you'll find the settings selector. These allow you to change the settings of the current mode. You'll see either 2 or 3 selectors available depending on which mode you've currently selected. Most selectors step through discrete settings, indicated by a colour. The colour order is always the same, so you can keep track of where you are, and different settings have different amounts of selectable options ranging from 2 to 5. While most setting selectors are discrete, some control continuous values. Rather than stepping through discrete settings, continuous selectors display a pulsating point on the touch strip, which represents your current value. Sliding your finger adjusts the value, with the default value indicated via a change in colour. Any selector, discrete or continuous, can be returned to its factory state by pressing it and holding it for 3 seconds. All settings are remembered after power cycles, so you'll find the module just as you left it. Next we have the voltage range selector at the bottom of the touch strip. This is where we edit a mode's input and output voltage ranges. It's important to remember that these ranges are set separately for each mode. By default, Gliss's voltage ranges are set from 0 to 10 volts, but can be configured anywhere in a range between -5 and 10 volts. To access the voltage range menu, tap the blue voltage range selector. From top to bottom, these three gold selectors represent the input, top output, and bottom output voltage ranges. There are two ways to customize the voltage range. You can choose a preset or set the range manually. Tapping the selector will cycle through the preset ranges, which will be displayed on the touch strip. These are 0 to 10 volts, -5 volts to 5 volts, 0 volts to 5 volts, and the full range, -5 volts to 10 volts. If you want to configure a custom voltage range, then you can set it up manually. From the voltage range menu, hold the selector for the input or output you want to customize for 2 seconds. After 2 seconds, 2 touch points will appear on the touch strip, which represent the minimum and maximum voltage levels for this input or output. Using 2 fingers, you can drag these points to your desired voltage range. The voltage range is quantized to 1 volt steps. Removing both fingers will set the range to the selection and bring you back to the voltage range menu. Push the button to return to performance mode. The last part of Gliss's menu system is the global settings menu. To enter the global settings menu, hold the button and tap the touch strip with 3 fingers. This menu includes settings that you'll likely only need to set once, and these settings apply across all modes. From top to bottom, these select touch sensitivity, LED brightness, menu animations, and module orientation. The first selector is touch sensitivity. This selector allows you to adjust the sensitivity of the touch strip to make it feel just right. This is done by applying a gain to the touch size. After tapping the selector, slide your finger to move the pointer to either increase or decrease touch sensitivity. This is particularly useful if you would like touch size to behave like a gate signal. With sensitivity set high, even a light touch will output the maximum voltage, which will be held there until you lift your finger. The next selector adjusts the brightness of the LEDs that illuminate the touch strip, so you can customize the brightness for maximum visibility in whatever context you find yourself. The third selector toggles animations on and off. To turn the animations on, you'll need to hold the selector down for 3 seconds. When animations are active, the selector will pulsate. When animations are turned on, and you push on a selector in each of the menus, you will now see an animation played back which will remind you of what that selector does. Hold the animation selector again to disable animations. The selector will stop pulsating. The bottom selector of the global settings menu is for switching the module's orientation. Gliss comes assembled with a faceplate that puts the jacks and button at the top of the module. A second faceplate is available with the jacks at the bottom. Hold press the orientation selector. All other selectors will disappear. You can then drag the selector towards one or the other extremity of the module. The selector should be at the bottom of the module according to the orientation it has in your rack. Let go of the selector once it's in the desired position. Control mode allows you to generate CV signals with the touch of a finger. In this mode, you can generate finger position and touch size signals. Let's make a simple patch. Let's use position to control the frequency of an oscillator and touch size to control its volume. Entering the menu and tapping Selector 1 turns the selector orange, which takes you into dual slider mode. This splits the touch strip into two independent sliders tracking your finger position. What dual slider provides is the means to control two parameters with position simultaneously, which opens up a slew of new control possibilities. The final setting is dual touch, represented by a yellow selector. Dual touch splits the touch strip into two pressure-sensitive buttons, with the amount of contact made on each half being sent out to the respective output. Control Mode's second setting selector gives you three different options for latching. Latching means that an output will be held at its latest value when a given touch ends. By default, Control Mode is unlatched, which is represented by the red LED. This means that when you lift your finger off the touch strip, both CV outputs go to 0 volts. But if we enable latching by tapping the settings selector, the value will be held at its last point even after removing your touch. If we tap the settings selector again, it turns yellow. This enables latching for position but not for touch size. Here's an example of when this would be useful. Connect the position output to the frequency of an oscillator. Use the touch size output to trigger an envelope which controls the amplitude. Here we need position to latch, but size not to. The last thing you need to know about latching is that you can latch and unlatch values on the fly without entering the menu, which opens up some powerful performance capabilities. Simply press the button while your finger is on the touch strip, and both outputs will be held at their current level. Touch the touch strip again to go back to controlling the outputs directly, or push the button to unlatch. Let's bring together what we've learnt into a more developed patch idea. Here we're going to use Control Mode to work as a macro controller. This means we'll use it to control multiple values at once, which allows us to create large-scale dynamic change within a patch. Then with some on-the-fly latching, we'll be able to create some sudden contrasts in density that are perfect for building and releasing tension. Here we've connected one gliss in a single slider configuration to control envelope decay time and a host of timbral parameters. The other gliss is in dual slider mode, which we'll use to control the parameters of two effects. So now we can build the density by moving our fingers up the slider to reach a crescendo point. Then we hold that intense level by using the button to latch on the fly. All before unlatching to bring us suddenly back to our original starting point. You can release any latched values by pressing the button at any time. Record mode allows you to record custom gestures up to 75 seconds in length. Record mode also offers a variety of ways to play your gesture back, enabling a huge range of possibilities for creating modulation signals, such as custom LFOs, envelopes, and much more. As in Control Mode, the first setting selector in Record Mode changes the division of the slider. By default, in red, we have the single slider. Orange gives us dual slider, and yellow gives us dual touch, which is two pressure-sensitive buttons. The second selector in the menu gives us 5 different playback options for our recorded gestures. The default setting in red is loop. To begin recording your gesture, simply place your finger on the touch strip, and you can end the recording by lifting your finger. As soon as your finger is lifted, Gliss will begin playing back and looping your gesture indefinitely. Your gesture can then be triggered to restart from the beginning, either by tapping the button or sending a trigger to the input. You can overwrite your gesture at any time by placing your finger back on the touch strip. To erase your gesture, press the button for 3 seconds. In dual slider or dual touch mode, you have 2 independently looping gestures. If you press the button or input a trigger, both gestures will return to the beginning and then continue looping asynchronously. Also, both gestures can be independently overwritten. When the slider is split in 2, you can erase either gesture independently by holding your finger on the half you want to delete and hold pressing the button for 3 seconds. Next, in orange, we have trigger mode. When using trigger playback, the gesture will only play once when the button is pressed or when a trigger signal is received in the input. This makes your recorded gesture act like an envelope with a custom shape. On receiving a trigger signal, the gesture always plays from the beginning at the speed it was recorded. Don't forget that we're free to use trigger mode with a dual slider or touch arrangement, giving us 2 simultaneously triggered envelopes. For a simple example, we could use these 2 envelopes to control a VCA and the cutoff frequency of a filter. Let's try making a custom attack release envelope. First, make sure you're in trigger playback mode. Draw in the attack portion of your envelope. With your finger still on the touch strip, push the button to mark the end of the attack portion. Draw in your release shape. Now when you send a gate signal to the input, or press and hold the button, the attack stage of the recorded gesture will be played back and held at its final value as long as the gate stays high. Once you stop pressing the button, or your gate signal goes low, the release stage of the recorded gesture will be played back. If the gate time is shorter than the duration of the attack stage, Gliss will just play through the entirety of the envelope. Next we have clock mode, indicated by a yellow selector. Clock mode can record with or without a clock signal present, but to begin with, let's look at recording with a clock signal coming into the input. In this case, we have a clock module controlling a bass drum on the quarter notes, and hi-hats on 16th notes. We're sending a clock signal to Gliss at the end of each bar, so every 4 quarter notes. 1, 2, 3, 4, 1, 2, 3, 4. This is our minimum loop length. We can record sequences which are a multiple of this amount of time. The trick here is to use a submultiple of your clock to control the loop length on Gliss. To record, we press the button and the recording will start at the next clock signal received in the input. The button is red whilst recording. Press the button again to finish the recording, which will stop at the next clock signal received. In clock mode, while you're recording, you can lift your finger off the touch strip as many times as you want. We're in dual touch here, and we can update the recorded gestures independently by pressing the button and playing on one half of the slider. Both halves can have different loop lengths. If you play on both halves during a recording, then they will have the same loop length. To erase the recorded gesture, press the button 3 times quickly. You can also use this mode without a clock signal connected to the input. Without a clock connected, the loop length is just the amount of time you allow to pass between button presses. Similarly as with the clock, present, recordings made with dual slider or dual touch can be recorded separately or simultaneously. Whilst not recording, you can also play on top of the recorded gestures without overwriting them. This brings us to Wavetable mode. This mode effectively turns Gliss into a wavetable oscillator by controlling the frequency of the playback speed of the recorded gesture via a volt per octave input. To get the most out of Wavetable, we recommend setting the output range to -5 to +5 volts. This means that the outputs can be treated more like audio signals as they are now bipolar around 0, so you can connect Gliss to a Eurorack level mixer directly. In this playback mode, the timing of the playback becomes unrelated to the timing at which the gesture was recorded. The whole gesture, regardless of its duration, is used to fill up a wavetable, which is played back at the frequency set by the input CV. The wavetable is updated continuously while you are drawing the gesture. In this example, the oscillator's waveform is continuously updated. If you want a more complex timbre with overtones and partials, then try drawing a gesture with more discontinuities in it. Take note that the input voltage tuning the oscillator follows the 1 volt per octave scaling convention. For this playback mode, any customized voltage input range is ignored. Your recorded gesture can be updated at any time. You can also use dual slider or dual touch input to get 2 simultaneous wavetables. The pitch of both oscillators will be the same, but they will have different timbres depending on the gesture you record. The final option here is Waveshaper. In Waveshaper mode, you can control the position of the playhead that reads back the recorded gesture. Similarly to Wavetable mode, the gesture is stored in a wavetable, but this time the CV input sets the portion of the wavetable which is being read at any time. For instance, sending a CV input corresponding to the minimum of your input range will play back the very first frame of your gesture, and sending an input corresponding to the maximum of your input range will play back the very last frame. Here we are playing back the gesture with a sawtooth wave. Notice that the wave shape we've drawn in plays back from the beginning to end as you'd expect, given how the sawtooth ramps from the minimum to the maximum of the input voltage range. Also notice that the rate of playback is controlled by the frequency of the control signal at the input. If we connect a triangle wave instead of a saw, the gesture will play forwards and then backwards. You can also use an attack sustain envelope to create a one-shot playback of your gesture. Here the attack time would control the playback speed. Other sloped modulation sources are also good candidates for scanning through the gesture, such as smoothly fluctuating random voltages or complex LFOs. In signal mode, you can visualize, scale, offset, clip, and smooth CV or audio signals, ready to be passed around your system. In this mode, any signal connected to the input will be visualised on the touch strip and passed to the outputs. To scale and offset the signal, place a finger on the touch strip. 2 gold points will appear on the touch strip representing the minimum and maximum voltage of your signal. The signal is being scaled and shifted between these 2 endpoints. With 2 fingers, you can move both the points at once. You will see the animation of your input signal between your fingertips. Signal mode has 3 setting selectors: input signal, output mode, and envelope decay. Selector 1 decides whether the input signal is treated as a CV or an audio signal. The default setting of this mode is for CV signals. However, if you want to work with audio, you'll need to change this setting. Tap the selector once to switch to audio mode. Press the button to exit the menu. As we're now receiving audio, the visualization shows a view meter. The second selector is output mode. This determines the type of signal that's passed out of the top and bottom outputs. There are 3 options. The first setting passes the processed signal to the top output, and by processed signal we mean the scaled and offset version of your input signal, and it passes an inverted version of this same processed signal to the bottom output. Tap the selector to move to the second setting, processed signal and envelope detector. This passes the processed input signal from the top output and a smoothed envelope of this signal to the bottom output. Tap again to move to the third setting, envelope detector / inverted envelope detector. This passes a smoothed envelope detector out of the top output and an inverted version of that envelope detector out of the bottom output. The third setting is envelope decay. It controls how quickly your envelope follower falls. Tap the setting to change it. Then slide the pointer to the top for maximum decay, or the bottom for minimal decay. The last function of signal mode is clipping, which allows you to set a threshold beyond which your input signals are squared off. This works in basically the same way on both CV and audio signals, but let's begin by looking at CV input. We know we're in CV mode because we can see the input visualized as a green pointer, which we can scale and offset at will. To enable clipping, tap the button and you will see 2 red points appear on the slider. Now put your fingers on the touch strip to select the range you'd like to clip. The signal within these clipping points will be clipped and rescaled to the full voltage range you've chosen. With audio signals, clipping can have some interesting effects. An audio signal has positive and negative components, which we can clip independently. Adjusting the positive and negative halves independently produces hard clipping, which can produce some interesting distortion effects. This can be used for an almost lo-fi, quick and dirty amplifier for line level signals going into your Eurorack. Notes mode turns the touch strip into a set of tuned notes. These notes can either be played like a keyboard with expressive glissando and vibrato, or like a sequencer where the notes are triggered one at a time by an incoming clock signal. The first selector chooses the play mode. Shown in red and chosen by default is the keyboard play mode. This play mode means you can play 5 notes with your fingers, and it also gives you access to some expressive features, namely vibrato and glissando to slide between notes. The other play mode is sequencer. This allows you to play through your 5 notes when a clock or trigger signal is sent to the input. Touching a step while the sequencer is playing resets the position of the sequencer to that note. The second selector is for quantization. We'll cover this function in greater depth when we talk about tuning the notes. By default, quantization is off, but tapping the selector toggles it on. Selector free is a continuous setting that controls a different parameter depending on whether you're in keyboard or sequencer mode. To alter the setting, tap the selector and then move the pointer to your desired value. When using this mode as a keyboard, this setting controls the amount of vibrato. Slide to the bottom for minimum vibrato, or slide to the top for maximum vibrato range. When you're using Gliss as a sequencer, this setting controls the amount of glide between notes. Notes mode comes configured with 5 notes pre-tuned, but the tuning of the notes is fully customizable. To tune the notes, make sure you're in the active mode rather than the menu. Press the button rapidly 3 times. The notes on the touch strip begin to pulse when they're ready to be tuned, and the button turns solid red. To tune the note manually, press and hold the key you want to tune, and a flashing point will appear. Keeping your finger on the touch strip, slide to the flashing point to start tuning the note, and then slide to adjust. The voltage being adjusted will be sent out of the top output if in keyboard play mode. Note that by default there's no quantization, which gives you a continuous range of voltages to choose from. Here's where the quantization setting can be useful. It can be difficult to achieve a precise voltage level when tuning manually, but if we turn on the quantization, then your voltage range is divided into 12-tone equal temperament semitones. Adjusting the output voltage range to be smaller can make it much easier to tune the notes manually, as we cut down the number of octaves available. It can be hard to store the accurate position of your finger when you lift it off, as the position may change slightly during the release phase. If you need more accuracy than is provided by this method, you can press the button while your finger is still on the touch strip. This stores the exact voltage. When you're finished tuning, press the button to return to active mode. You can also tune the notes based on the CV input, which allows you to sample incoming voltages and store them into each note. Enter the tuning menu in the same way as last time. Press the button 3 times. Use an external voltage source to generate the desired voltage and plug it into Gliss's input. In this example, we are using the octotrack to generate different notes, and sampling them on Gliss's virtual keys. The input will be passed through the top output of Gliss while in tuning mode, so you can preview it. To store the incoming voltage to a note, simply press the corresponding note. The keys are also sensitive to touch size, which comes out the bottom output. Touch size can be used to directly control the volume of the oscillator you're controlling, but it's also a perfect source for generating gate signals to trigger envelopes. Remember that if you would like touch size to behave more like a gate signal, you just need to increase touch sensitivity to its maximum value. You can customize the number of keys on your keyboard from 1 to 5, which will correspondingly increase the space on the touch strip assigned to each note. To change the number of notes, make sure you're in active mode and press the button twice. The button will pulse red. Now you can enable or disable the notes by tapping them. Only the enabled notes will appear in your keyboard once you exit the menu. Confirm your choices by pressing the button once. You'll notice that each of your notes are laid out to the full length of the touch strip. Each of these will have the tuning previously assigned to them. Now let's look at how to configure the sequencer play mode. Using the notes as a sequencer means you can trigger the notes in order using an input signal. The top output sends the tuned voltage for the active note, and the bottom output sends a trigger. The trigger is 10 volts if the current step is the first in the sequence and 5 volts otherwise. You can choose the next active step on the fly while the sequencer is playing. Just tap a note and that selected note will be played next and the sequence will continue. The behaviour of each step of the sequence is configurable. To configure your steps, make sure you're in active mode and tap the button twice. There are 4 possible states for each step. The first is active, represented by green. This means the notes will play when triggered. The second is hold, represented by gold. The previous note will be held until the next input trigger, and no trigger is sent to the output. You can also choose to mute a step. This is represented by red. This means the step is still in the sequence and 0 volts are sent out to both outputs. The fourth state is skip, which turns the step light off. This removes the step from the sequence and shortens the overall sequence length.